is the power rule. If y equals x to the n, then the derivative is n times x to the n minus 1. Now we're going to prove this for n equal 1, 2 on out, for a constant, whole positive number. When we do implicit differentiation, I'll be able to prove it for all n, but right now we just have it for the positive integers. So first off, I want you to remember Pascal's rule. Nope, Pascal's triangle. Long night. This gave us the coefficients when we multiplied a binomial out. So let's say I have a plus b to the 1. That's equal to a plus b. The coefficients are both 1. My triangle starts with a 1 and a 1. If I have a plus b squared, that's an a squared plus 2ab plus b squared. So notice my coefficients are a 1, a 2, and a 1. If I cube it, my coefficients will be a 1, a 3, and a 1. If I raise it to the 4th power, I get 1, 4, 6, 4, 1. Notice that the second term is always the power that you raised it to. So if I have a plus b to the nth power, I will have a to the n plus n times a to the n minus 1 times b plus, I actually don't really care about what the next constant is, so I'm just going to say k1 as a placeholder. And on down to b to the nth. Okay, so I'm going to use this fact to show that the derivative of x to the n is n times x to the n minus 1. So proof. Let f of x equal x to the n. Now we know the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So I'm going to plug this into my formula. I will have x plus h quantity to the n minus x to the n all over h. Next thing I need to do is I have to expand that x plus h to the n. And write all this stuff down again. Okay, so x plus h to the n, I'll have x to the n plus n times x to the n minus 1 times an h plus that coefficient that I didn't really care about, I'm going to call it a k1, x to the n minus 2 times h squared. Notice the powers of h's are going to keep going up until finally I get to h to the n for the expansion. And then to do my derivative formula, I have to subtract x to the n. And that's all over h. Now, x to the n at the beginning minus x to the n at the end, they cancel out. And I can pull out an h from the leftovers. Everybody else has at least one h. So I have h times n times x to the n minus 1 plus constant I didn't care about, x to the n minus 2 times an h. Because that's squared, I still have an h. On out to h to the n minus 1 all over h. So those h's cancel. The reason I was harping on all these h's is all of these terms have an h. So as h goes to 0, all of these terms will go to 0. So the only thing that survives is n times x to the n minus 1. That's what we're trying to prove. So the derivative of x to the n is n times x to the n minus 1. And this is true for all real numbers, and we just proved it for the natural numbers.